Alrighty, so in this video we are going to start using the skills from the previous video when we were simplifying radicals in order to start using our algebraic ways to solve quadratics, which is going to be a lot easier than having to graph them each time and use our graphing calculator. So what are the solutions to the quadratic equation? Remember, they are the x-intercepts, also known as zeros, solutions, and roots. Okay, so graphically they're where they cross the x-axis. Okay, how many are there? So you remember, if you think about a parabola, there could be 2, there could be 1, or there could be 0. Okay, there's 2, 1, or 0. So square root property, this is our first method. To undo, and we already talked about this a little bit in the previous video. To undo something being squared, take the square root of both sides. Okay? And we use this method because there's going to be several methods. There's going to be 3 total methods that we talk about in this unit. So we use this method and this property if the quadratic equation does not have a b term. So for example, ax squared plus bx plus c equals 0. If that's the case, there can be no b term. Okay? There can just be an x squared and a number. Because what we're going to do is, you'll see we're going to get the equation in the form x squared equals a number. Then we're going to square root both sides. And what's going to happen when we square root both sides is that a plus or a minus is going to show up. Okay? And the reason it does that, and maybe I'll wait till example 1a, is because remember, there are 2 solutions here. Most likely, out of most of the situations we're going to deal with, is that there are 2 solutions. And so by taking the square root, we are going to get the positive and the negative solution. We're going to get 2 solutions, 2 zeros. Okay? One big key concept is that you cannot take the square root of a negative number. If you try it in your calculator, you're going to get an error message. So if you're taking the square root of a negative number, what actually is going to end up happening is that there are no solutions, which means there are going to be 0 real solutions, which means that the quadratic does not cross the x-axis. Okay, so solve each equation. X squared equals 121. This is already set up beautifully, because all I need to do in order to get the x by itself is take the square root of both sides. Okay, so x is going to be equal to the square root of 121, and that turns out to be plus or minus, we have to remember our plus or minus 11, because the square root of 121 is 11. So why do we need to do the plus or minus business? 1, there are 2 solutions to a quadratic, so we need to find both of them. 2, if I checked this work, okay, if I plugged my solutions back in, 11 squared is going to equal 121, so that checks out. And negative 11 squared is going to be 121, so that checks out. Because a negative number being squared, negative times a negative is going to be a positive. Okay, so we need the plus or minus. That part's going to be key. If you leave off the plus or minus, you're going to get a point taken off because you don't have both solutions accounted for. Okay, let's go over to B. We got m squared minus 56 equals 0. So this is almost close to being ready, but we need to get the m squared by itself. So I'm going to add 56 to both sides. So I get m squared equals 56. Then I'm going to take the square root of both sides. So m is going to equal plus or minus square root of 56. But 56, that's not a nice perfect square. So what we need to do off to the side is simplify that radical. So 56, I know 2 goes into it, and 2 goes into it 28 times. Still no perfect square. Okay, so 28 breaks down into, I know 2 goes into it. I know 14 goes, 2 times 14. It's going to give me 28. Still no perfect squares. Break this down again into square root of 2 and square root of 7. Still no perfect squares. But remember, we can buddy things up. Like these 2's get to buddy up. And if you have a buddy, you get to come outside. Okay? So, plus or minus, a 2 gets to come outside. But you'll notice this 2 and this 7, they don't have buddies. Okay? So they're stuck underneath. And they get to multiply underneath. And so I'm going to get plus or minus 2 square roots of 14. That one's a little tricky. Okay? But yeah, square root of 56 breaks down and the buddies get to come outside, and anything that's doesn't have a buddy, doesn't get to come outside, is going to multiply together and stay underneath the square root. Okay? So that wraps up B. Zoom back out. Let's look at C. So here we have something that's grouped together being squared. That's fine. I still want to undo the squaring. So I'm going to take the square root of both sides. But if you'll notice right here, that's the square root of a negative number. And we cannot take the square root of a negative number. If you try it in your calculator, you're going to get non-real answer. So it doesn't work. So this isn't going to have any nice number x-intercepts. This is not going to cross the x-axis. This is no real solutions. If I were to graph this, I would not see it cross the x-axis at all. Okay? We cannot square root negative numbers. Don't try, because it's not possible. Okay? Not possible yet. Going over to D. So this one is actually going to work out a little bit better. I can square root both sides. So I've got x plus 9 over here. Square root of 64, that's a nice number. So that's going to be plus or minus 8. No, I'm not done yet, though, because my x isn't totally by itself. So I'm going to split this up into 2 equations, because we've got x plus 9 equals positive 8, and x plus 9 equals negative 8, because there are 2 possible solutions when I'm dealing with this quadratic. All right, so now I'm just going to go back to Unit 2, solving these equations. In this first one, I'm going to subtract 9 from both sides. 8 minus 9 is negative 1. So x is going to equal negative 1 there. Here I'm going to subtract in my second equation. Subtract 9 from both sides. Negative 8 minus 9, that's going to give me negative 17. Okay? Remember, what this means is that if I were to graph this quadratic, what's going to end up happening is that it's going to cross the x-axis at negative 1 and negative 17. We need to include both those answers because both of them are solutions to this quadratic. Oops. E. Let's wrap these 2 up. Okay, so in E, I'm going to add 10 to both sides. So then I get 2a squared. Because our end goal is to get a squared by itself. So I'm going to add 10 to both sides. Then I'm going to divide by 2. So then I'm going to get a squared is equal to 50. When I take the square root of both sides, square root of 50 is not a nice number. So square root of 50, that can break down into square root of 2 and square root of 25. Square root of 25, well, that's a nice number. That's 5. So 5 gets to come outside. So a is going to equal plus or minus 5 square roots of 2. All right. And then wrapping up this last one, our end goal is to get this group being squared by itself. So the first thing I'm going to do is add 1 to both sides. So I get 4 times the quantity k plus 1 squared equals 36. I'm going to divide both sides by 4. So I'll get k plus 1 squared is equal to 9. Square root both sides. So k plus 1 is equal to square root of 9 is a nice number. That's 3 plus or minus 3. So now I'm going to split this up into two equations. K plus 1 equals 3 and k plus 1 equals negative 3. When I solve both of those, I'll get k to equal 2 and k to equal negative 4. And I need to include both of those answers in my solution, okay? Because they're both x-intercepts. They're both solutions to this quadratic. So, lots of problems that I just worked through for you. I have 1, 2, 3, 4 more that I want you to work on, okay? Quiz in Schoology to submit your answers. And that's going to wrap up our first algebraic method in order to solve quadratics, which is square rooting both sides.